Hello everyone, good morning. This is KP the Math G, as you can see up here. We have been doing a lot of limit here recently, but now the limit has gotten ourselves into the derivatives, and we've been looking at techniques of differentiation. The last video that I did one on the power rule, and of course we're going to apply that to this. This is called the product rule, and of course if there's a product rule there is a quotient rule. The product rule is simple, is simply this: if y is equal to g at x times h at x, then dy over dx, that's another way to say the derivative. When x is in the denominator, you're taking the derivative of x. If y is in the denominator, you're taking the derivative of y. In this case, dy over dx, we're taking the derivative of x. So g at x, nothing done to it, times this prime means we are taking the derivative of the h function, and then again plus sign, always a plus sign, never a minus. Now the second time around we're taking the derivative of g times h. Okay, so we have a polynomial, and there are others that we put two polynomials together. The only reason we're dealing with just polynomials is that we haven't looked at the derivative of the trig functions, the exponentials, like e to the x, ln of x, and so on. And I guess we could go ahead and do that, but we will reserve that for another lesson. So there are other derivatives that we haven't covered yet. So we're just dealing with polynomials. And I would say polynomials, there are some that are not really polynomials. They have negative exponents on them. So we're dealing with that. We're just going to look at it with this regard at this time. We'll call this portion right here g at x, and we'll call this portion right here h at x. Okay, let me get a, so we'll say this is g at x and this is h at x. Okay, like that. Okay, alright, so let's apply the derivative using the product rule. Now, one thing you can do to avoid the product rule is that you can, and this is not always the case, but you can, with these two polynomials, you can distribute you can multiply this first and then just apply only the power rule, and you'll get the exact same answer. Ever how you want to do this, again, but we're just applying the principle to it right now. So in other words, we're not doing anything to g, so we're going to leave g alone. The g function as is. Now this part right here is we're taking the derivative of this. Okay, so if we want to just write it out, I guess we can. Let's just write it out. 3x to the 4th minus 5x cubed plus x. We're taking the derivative of that. Alright, so plus sign. Now we're taking the derivative of this, of the g function, x cubed plus x squared. We're taking that derivative. Oh, am I going to have room to put this? So let's see here. We might can fit it in here if we write small. 3x to the 4th minus 5x to the 3rd plus x, and yeah, we can fit that in there. Notice that here we're taking the derivative of h but not to g, and then this time we're taking the derivative of g but not to h. Well, let's do this now. dy over dx. Good thing I have a board that flips over so we can finish the problem on the other side. I'm probably just going to have to get a pencil and a paper and write down what I've got down at the very bottom so I can flip that over and see what I've got. Okay, so let's look at the first part. Do nothing to it. Okay, alright, I'm doing nothing to that. Alright, now let's take the derivative. Now remember, this is the power rule. We can apply that power rule to this. 3 times 4 is 12, x to the third power. 3 times 5 is 15, x to the second power. And then remember here, 1 times, let's put a 1 here, 1 times 1 is 1. And remember, this is, you subtract the exponent by 1, that is x to the 0, which is just 1. So if you see x, you just simply write 1. Please do that. Alright. Something that was weighing on my mind from the last video, which the last 2 videos have been cutting off, but I did allude to something about, making $13 an hour. Then that was great. Now it's not so great. And that's probably true, but there are some people who work for $13 an hour, or maybe even a little less, and that's what they earn, and I don't mean anything by that. So just kind of keep that in mind. That was weighing on my mind. I felt like, well, I should not have said that at all. So please forgive me if I have said something that's inappropriate there. Okay. All right, moving on. Okay, so once again, plus sign here. Now we take the derivative here. This is 6. Let's see, 6x. Take 1 off, squared, plus, now put a 1 here. 2 times 1 is 2. 2x to the first power. I don't put a first power there. Just understand that that is a 1 there. And we're not doing anything with this latter part. 3x to the fourth minus 5x to the third plus x. And really and truly, that is your derivative. And this is one of these problems that if you're doing a open response or free response question here, that this may be all you have to do once you find that. We could go a little bit further and distribute and then collect like terms, but basically that is, we just did the derivative. I'm not thinking about flipping the board over, but I would have to do that if we decide that we want to multiply this out. We can do this. By the way, incidentally, this represents the slope of a tangent line. Can you imagine y equals m? M is all of this. X plus b. Alright, y is equal to mx plus b. Or y minus y1 is equal to m times x minus x1. That's crazy, isn't it, though? But yeah. It does represent the slope of the tangent line. It also represents instantaneous velocity, as we've been pointing out, and many other things. But it is definitely a rate of change, whatever it is. Okay. Okay. So that is what we have here as far as that goes. I mean, if we want to, we can multiply this out, but we have to be very careful. I may try to go ahead and do that. 2 times 12, 24, x cubed is x6. Alright, and then minus 30. 30 x 3 x2 is x5. Alright, and then plus 2x cubed. Be very careful with these problems, I'm telling you. Now this term here is going to be plus 12. 1 times 12 is 12. X to the fifth. Let's see, maybe I can put that underneath here. Plus 12 x to the fifth, since I have a like term here. Let's see, minus 15 x to the fourth. And since I don't have a fourth to the fourth power, I will just leave it right there. Alright, and then plus 1x squared, or just x squared. Okay, and then of course we can distribute this also. Let's see, plus, keep going, 6 times 3 is 18, x to the 6th power. I think we can put that over here. 2 plus 4 is 6. 6 times 3 is 18. 18 x to the 6th power. Alright, that's good. Alright. 6 times 5 is 30, but that's negative 30 x to the 5th. So negative 30 x to the 5th. Alright. Alright, we need to keep going here. 6 times 1 is 6, and 2 plus 1 is 3. Alright, so 6x to the third, okay, plus 6x to the third. Alright, there we go. Got that stacked underneath the cubes here, so I can easily add that up. So we did get these first three terms, didn't we? Now let's get the last three. 2 times 3 is 6. 1 plus 4 is 5. Oh, we got another x to the fifth. We might have put it right here. Let's see. 6 times 3, no, I'm sorry. 2 times 3 is 6. 1 plus 4 is 5. So this would be 6x to the fifth. 6x to the fifth. Okay, I don't have any more room to stack, so that's about it there. Alright, 2 times 5 is 10, but it's minus 10x to the fourth. Okay, I can put that down here. So, minus 10. Okay, and let's see what we got at the end here. X times x is x squared, so 2x squared. Well, maybe we have enough room to put all of this here. And again, barred that we didn't make a mistake, everything's going to look all right. So dy over dx. Let's see. 24 plus 18. 4 and 8 is 12. Alright. 10 plus 1 is 3, plus 1 is 4. So 42 x to the 6th power. Alright, I wish I had somebody helping me out here. Alright, so let's see. Minus 30 is minus 60. Alright, so let's see. Minus 60 plus 18. Alright, 6 plus 12 is 18. So minus 60 plus 18, and that's x to the fifth. Alright, so the fifth. 10 minus 8 is 2. And 5 minus 1 is 4. So minus 42. Ooh, I'm hoping I'm right on that. X to the fifth. Okay. I borrowed that again that we did this correctly. Alright, now let's see. 12 plus 2 plus 6. So 2 plus 6 is 8. 8 plus 2 is 10. So 20. So plus 20x cubed. Well, actually, I could do an x to the fourth. Alright, so plus 20 x cubed. I'm going to put plus something here, x to the fourth. Well, maybe minus, I don't know. Put minus, it looks like it's going to be minus. 15 plus 15 is 30, plus 10 is 40. So minus 40 x to the 4th. Okay, and then let me erase this. Don't need this anymore. Alright, I do a lot of things by hand, so sometimes I get in trouble for it. Alright, so 1 plus 2 is 3, so plus 3x squared. And by the way, we do have a plus 1, don't we? So plus 1. And that, if you were looking for a multiple choice answer, this could be it here, or this could be it. And sometimes I wonder if you know, the thing about it is, they don't want you making any further mistakes. So if you get down to here, and usually you're not doing a product rule with two polynomials anyway. Okay. All right. So again, we didn't make mistakes. Now I'm not going to look back at this. I'm really not. I'm just going to say this is it. That I was careful enough to get this. So, all right. Okay, we're going to move on to the quotient rule, and we're not, I repeat, not going to, maybe not anyway. Okay. All right. So this is it here. Let's do a quotient rule. Matter of fact, let's probably just flip the board for that. How about that? Makes it faster. Now, let's look again. The product rule. Put it up here. All right. Remember that you have two functions, f and g or whatever. So let's see. If h at x is equal to f at x, I probably should just leave it like I had it last time. What was that last time? G. Let's see. What two letters did I use? G and H. Okay. Okay. If y is equal. Okay. So if y is equal to g at x plus, no, times rather, sorry, times h at x. Now one thing you can do, you've got to remember, y prime or dy over dx, let me just emphasize on the product rule, there's actually, you can write this in several ways. One way is you could say, well, leave the first alone and take the derivative of the second. All right, that's the derivative. That h prime at x is the derivative. Not forgetting to use the plus sign right here. And then now take the derivative of the second, okay, times the first, okay, or times h, the first times the second. Another way you could look at this is, well, maybe does it matter? In other words, if you forget and say, well, KP the math G, does it matter that I do G prime first? No, because if you take a look at this, there's G prime times H. All right, so the first time we're leaving the second one alone, the second function alone. And then this time around we're not doing that, and then times h prime at x. Well, if you notice, you have exactly the same thing. This and this are the same, and this and this are the same. So which one you want to do first? You want to take the derivative of the first times the second plus the first times the derivative of the second. Okay, either way you want to look at that. Okay, and there's other ways we could write this. Some people leave the derivative, like in other words, okay, I'm just going to do one more. The derivative of the first the first times the second, okay, times the second, alright, plus now the derivative of the second times the first. Alright, second, first. Alright, first, second. Okay. Maybe some people want that pattern where you're doing derivatives first. Derivative of the first times, or even you can do the first times the derivative of the second, plus the second times derivative of the first. Doesn't matter. Still get it all. It's all the same. You're going to get the same answer no matter what you do there. Okay. So that's the luxury that you have with this, and the plus sign, that addition is commutative. A plus B equals B plus A. So I mean that's quite all right. It's not the same with minuses, but A plus B is the same as B plus A. So there we go. And that probably needed to be brought out. So that was the product rule. Alright, so now let's do the quotient rule. Excuse me. Let's look at that. If y is equal to, let's change it up. Well, we don't have to. G at x over h at x. Alright, and there is I can't remember the saying that tells you a little bit how long I've kind of been out of calculus. It's been 3 years since I've been out. So low d high, minus high d low over low squared. I still remembered that. Low is the denominator and the high is the numerator. So here we go. Then, and we can even say y prime, or we've been sticking with dy over dx, so we'll be consistent. Dy over dx. Okay. We call this low, which is really the denominator. Alright, high. Okay, alright, so low, which I'm not really, low is h at x times the derivative of the high. So what you're doing is you're moving this up. You've already made a move on h. Now make a move on g prime at x. And this time, guys and girls and pretty squirrels, this is a minus sign on the, there's no squirrels here, okay. Squirrels can't do that, okay. Squirrely people like me can, but I'm not a squirrel. Okay, anyway. Everybody asked, are you sure? Yeah, I am sure. Alright, low d high minus high. Alright, high is g x. Now, times the derivative of the low. Alright, then divided by low squared. Okay, there it is. Some of these can be manipulated, but we'll worry about that later. Okay, now where's my pad? I had an example on it. Let me reach. Okay, here we go. Here's the quotient rule. Let's try it. Let's get y to be equal to 3x cubed minus 4x. That's the high. The low would be 2x squared. 2x squared plus 5. Okay. Now, what is dy over dx? That's what we're going to find out. Okay. Again, low, high. And the reason we say low, high, it kind of rhymes. Low d high minus high d low. Okay. I guess that's one way to remember it. Okay, so here we go. Low. Bring it up. So that you already made a move to your denominator. That's the move. You moved it to the numerator. Now let's do this. Let's take the derivative. We're going to take the derivative of that minus now this part and then the derivative of the high, of the low rather. High d low over low squared squared. All right. Whew. Well, let's plot that now. Okay. And again, we usually don't use polynomials to do this, but we're going to do it here. All right, so here we go. The first one is just do nothing to. You just bring that up to the numerator. That is the move. You moved it up. Okay, now right here, make a move on this. 3 times 3 is 9. X to the second power. Remember, reduce the exponent by 1. This is 1. 1 times 4 is 4. 4, whoa, that's it. Because remember, if it's to the 1 power, the x is gone. Because this is x to the 0, which is 1. 4 times 1 is 4. Okay, there it is. Anytime you just have x, just write that number, 4. Okay, here we go, minus sign. Okay, I like to do this. I'm just a sticker with doing that. Okay, so now this one is we're doing nothing to 3x cubed plus 4x, or minus 4x rather. Now see, if you make a mistake there, you just messed up your entire problem. And I almost made a mistake there, but that's almost. Okay, now take the derivative of this. 2 times 2 is 4. 4x, and remember the derivative of a constant is 0. We don't need to put plus 0 here. That's good enough here. And over low squared. Well, let's square this. This is going to be 2x squared plus 5 times 2x squared plus 5. The first term is squared. This is 4x to the 4th, isn't it? Okay. Let's see. We multiply these two together. We got 2 times this. We're doubling it. 2 times 5 is 10. So 10 plus 10 is 20. So plus 20 x squared. That's it. And then 5 times 5 is 25. So that's it there. Okay. If you want to move on and do this, we can. Let's do it. dy over dx. Okay. Once again, let's see. 2 times 9 is 18. X to the 4th. 18 x to the 4th. 2 times 4 is 8, but that's minus. So minus 8 x squared. Okay. 5 times 9 is 45. That is 45x squared. Let's see, well, let's just go ahead. 45x squared. And then the last term is minus. So 5 times 4 is 20, so minus 20. Okay. Okay, minus sign. And I'm going to do this. Okay. 4 times 3 is 12. And x1 times x cubed is x to the 4th. Okay, that's that. Very good. Oh, good. We only have one term here. Now 4 times 4 is 16, but it's minus. 16 x1 plus x1, well, x1 times x1 is x2. Alright, now again we just distribute that now over the denominator. 4x to the 4th plus 20 x squared plus 25. I think we have room for one more little area. Okay, maybe not. I'm not sure. Put a little line here. Let's keep it separated. Ooh. Okay, let's see if we do. We can combine these. Let's see, we can actually distribute here. I guess we might as well do that. If we go ahead and do it here, we're going to have a minus times a positive is a minus, and a minus times a minus is a plus. So I just went ahead and did that in one move.